Hello, welcome to Lab 6 of Opti 471B called Measurement of Off-Axis Aberrations. In this lab I'll go over the theory behind measuring coma and astigmatism, the experimental setup that is used to do that, and the results and how they compare to a simulation in Zemax. Coma is an off-axis aberration that manifests as a comet-like blur. This is caused by both the sagittal and tangential rays coming to a focus at a different place than the paraxial focus. Therefore, in order to measure coma, we can break the pupil up into 5 distinct locations using a Hartmann mask and measure where those rays map on the image as a function of the pupil location. We can perform a quite similar experiment to determine astigmatism. Astigmatism is another off-axis aberration that manifests as a difference in focus for the tangential and sagittal rays. Hence, we can use the same setup and determine the astigmatism by finding the difference in the tangential and sagittal focus. Our setup used a Heaney laser, a beam expander, and spatial filter, aligned using a shear plate interferometer to ensure collimation. This was followed by a turn mirror to create an off-axis point, the Hartmann mask to isolate positions on the pupil, the test lens, and the microscope to find the final ray location. The final beam picked up by the microscope was super dim because the Hartmann mask blocked out most of the light. So eventually, all the lights had to be turned off in order to align the microscope. The pinhole for the spatial filter and the collimation lens for the beam expander were selected using the same methods as in previous videos. The on-axis beam and the microscope were aligned also as described in previous videos. Then the combination of all 5 pupil points resulted in a grid-like pattern caused by interference. This also indicates that the microscope is at the marginal focus of the spherical aberration caustic, as this is the location where all the rays from the edge of the pupil cross. Next, the microscope was horizontally translated, and the turn mirror was tilted to create an off-axis point. This is seen by the crosshairs in the original beam spot being offset by a couple millimeters. Once the off-axis beam was established, both the coma and astigmatism measurements could be made. Coma was determined by measuring the translation required to find the focus for all 4 rays at the edge of the pupil. Astigmatism was measured by finding the difference in focus points for the sagittal and the tangential rays. After some calculation, the results were as follows. The tangential coma was consistently about 3 times more than the sagittal coma. However, the Seidel coefficient for the measured and the Zemax simulation were fairly different. The Seidel coefficient for astigmatism, however, was very similar to the Zemax simulation. Note that the simulated ray fans have both spherical aberration and coma. However, you can infer coma by taking the average of the 2 edge points. This is what the orange line describes, and is also how the measurement was done.